Here look at the voltmeter. This is the voltmeter. That one measures the voltage across collector and emitter. There the value of VCE is kept constant as 5 volt. Don't forget this. Throughout the experiment, VCE value should not be altered. The important parameter of the transistor is input impedance. The input impedance parameter of the transistor can be found out by drawing the graph called input characteristics curve. Are you clear? While measuring the input impedance, which one must be kept constant? VCE must be kept constant. What is VCE? VCE is called voltage across collector and emitter. The voltage across collector and emitter must be kept constant. Its value is set as 5 volt here. Throughout the experiment, the value of VCE should not be altered. Now, the VBE, voltage across base and emitter, must be changed, and the corresponding variation in the microammeter. Are you clear? Here we are measuring the base current. The base current is measured in the microammeter. No, that should be noted. So therefore VBE should be altered, IB to be noted. Now I am going to vary the value of VBE. Look at the graduation. Now first I am going to set the value of VBE as zero point 0.1 volt. Now it is kept exactly at 0.1 volt. Note down the reading in the base current. In the case of base current IB, no change. Therefore it should be taken as 0. For zero point 0.2, for VBE zero point 0.2, note down the reading is still 0. IB is 0. For 0.3, for 0.3, what is the reading here? Again it shows 0. IB is 0. For zero point 0.4, VBE zero point 0.4, what is the value of IB? Again it shows 0. 0 microampere. Now it is going to be increased from 0.4 to 0.5. Now the VBE value is 0.5 volt. What is the reading again? IB value is 0. Now it is increased from zero point 0.5 to 0.5 to 0.6. Now there is a small changes there in the deflection. Now it is coinciding with third division. Its least count is 5. Microammeter least count is 5. Therefore 3 into third division into 5 is 15. 15 microampere is the IB value. Note down. Now the value of EB is increased from 0.6 to 0.7. Now it is increased from 0.6 to 0.7. Now down. Now the reading is, it is exactly coinciding with the very important thing is without any parallax error we have to set the values. Are you clear? Now it is exactly at zero point 0.7 volt. It is coinciding with 28th division. So 28 into 5, how much? 140. 28th division is coinciding, least count is 5. 28 into 5 is 140 microampere is the IB value. So like that we have to measure the which one? The both voltmeter reading and ammeter reading. Here which one is kept constant? VCE is kept constant. Understood? Now we are going to calculate the input impedance of the transistor. Already by using the tabulated values, the graph is being drawn. In x-axis, the VBE values to be taken. In y-axis, base current IB are taken. By using the tabular column values, all the values are plotted and the graph is drawn. So after plotting all the values, after connecting all the points, you will get the graph like this. The shape of the graph, it will be like this. Now to calculate the input impedance, the formula is Ri is a symbol for input impedance. Ri is equal to del VBE divided by del IB. This is the formula. Del VBE means difference in base and emitter voltage. What is del IB? Difference in base current. In between these two, the ratio to be taken. Del VBE. How to calculate del VBE? Look at the graph. Here in del VBE, find out the maximum value. here if the graph, the values are after plotting the values, you have to draw the slope. I have drawn the slope here. Just you extend the line towards x-axis. This is the maximum value of VB. After intersection you will get the maximum intersecting point here, that is called, what is this? This is a maximum value. What is the maximum value here? 0.65. And look at the minimum value, intersection value, there you will be getting 0.62. Okay, look at the difference in IB. What is the maximum value? 80. Here if it is extended you will get the minimum value of IB, that is 40. So 80 minus 40 is a difference in value of IB, that is del IB, that is measured in microampere. Now you have to subtract. Now after subtraction you will get 0.03 volt. Okay, so after that, that is to be divided by which value? The EB value. Subtract, you will get 40 micro ampere. Okay, now calculate 0.03 divided by 40. The answer will be 0.00075. 0.00075. Here it is given in terms of microampere. Okay, so I'll extend the value 0.03 volt whole divided by microampere can be converted into ampere. 40 into 10 to the power of minus 6. If it is brought up, that one becomes 10 to the power of 6. After multiplication you will get 750 ohm. 750 ohm is the value of Ri. This is called as, what is this? Input impedance. Okay, so this is the method of finding the value of input impedance.